Hey all, welcome back. So in today's video we are going to discuss about some of the most frequently asked questions from Verilog HDL. So these are the questions. Okay, you can just pause this video and read these questions, and if you can answer any of these questions, you're most welcome to answer these questions in the comment box. And also, if you're having doubts in any other concepts within Verilog, you can also ping me. I try to explain it in my channel, right? So this is just like, feel it just like a mock interview. Try to answer any, at least try to answer how many questions as possible for you in the comment box, or try to answer this in any of my social media handles or also in my telegram channel, and also do ask all your doubts in any of my social media handles. So in today's video we are going to explain about all these questions. Okay, in this way I'll be conducting one or two videos on the remaining questions on Verilog as well as system Verilog also, right? And also, if you are new to this channel, consider subscribing this channel and hit on the notification bell also. And also do like this video and share your opinion on such videos in my YouTube channel, right? So these are the questions. You can pause this video and you can answer any of these questions that you like. So coming to the first question, which is differentiate between 2 equal to and 3 equal to symbols. So basically these are operators. Okay, if you already know it, just think it as a revision for all these concepts. So these are kinds of operators in Verilog. So this is the equality operator. Okay, and this is also equality operator, but this is case equality operator. So operators are categorized into two types, which is equality and case equality operator. So if you are having two equal to symbols, that is equality operator, and if you are having three equal to symbols, then that is a case equality operator. So coming to equality operator, when you are using the equality operator, then you can expect the output can be 1, 0 or x. But if you are using the case equality operator, then the output can be only 0 or 1. Why is it? Because for example, if you are taking some same like two inputs x and y, and x is having inputs like 0 1 x 0, and y is having inputs like 0 1 z and 0. Okay, so when you are comparing this with equality operator, what happens means 0 0 is equal, 1 1 equal, but x and z. So whenever you find x in the equality operator, then the output will be x or z. Either you find x or z. For example, if this is 0 also, since that is x and 0, comparing x and 0. So when x and 0 is compared, it will be giving the output as x in case of equality operator. But when you do the same thing with the case equality operator, then it will compare x and 0. Since x and 0 are not equal, so the output is not equal. That means the output can be 0 here. Okay, if it is equal, for example, if you are having 0 1 x 0, 0 1 x 0. So since both are x and x, so this output will be 1. But if you do the same thing in equality operator, since both are having x, so the output can be x. Okay, so that is how the differentiation occurs in both equality and no, case equality. As I told you now itself, so it can compare ones and zeros but not x's. X's can't be compared within equality operator. But when you want to compare this x and z values also, then you should go for case equality operator where all x's are also compared. That means x is compared with x. If x and x both are in same position, then it is equal. For example, if it is 0 1 x 0 and it is 0 1 0 x, then since the placement is different, so the output will be 0. Okay, so that's what I told you. You can have only two outputs, that is 0 and 1. X is not the option here. Why? Because x is also compared in case equality operator. Got my point? So this is the difference between equality and case equality. When you were asked in the interview, you can just answer it in this way, like it can compare zeros and ones but not x's, and whereas a case equality operator can compare x's also. Okay, so the output can be either 0 or 1. Here the output can be 1, 0 or x. Right, this is how you have to answer in your interview. Now coming to the next question, what are blocking and non-blocking interviews? This is the most frequently asked question in your Verilog. Okay, okay, so let us see first what is the answer for this. So the blocking assignment completes the entire statement before control goes to the next statement. Okay, so it is similar to the old programming languages, and the symbol for blocking statement is equal to, whereas the non-blocking statement evaluates the right hand side of the current time, and then until all the right hand side evaluation is done, it won't go for the left hand side. Until all the right hand side evaluation is done, then the left hand side later at the end of time unit, that means at the end of the, at the last statement of the right hand side, then the evaluation of left hand side takes place, and it is symbolized by this less than or equal to symbol. Okay, so now this is what you have to answer when you enter into any interviews. But if you want to know deep about this, what is blocking and non-blocking, I have already made a video on that. I will link the Verilog playlist where I have explained each and every topic within Verilog. You can just check out this playlist in order to know every topic in detail about this concepts in Verilog. But as for today, let me be some more deep about this topic, because many of you will be having a doubt on what is this blocking and non-blocking concept in Verilog. So let me explain it with a small example for you. Here, if you see the example, okay, x is less than or equal to. That means you should say that this is the non-blocking statement. Okay, let us see the same thing with blocking and non-blocking. For example, if it is mentioned in this way, like x equal to a or b, y equal to ax or bx or c, and z equal to b and negation of c. Okay, this is the blocking statement, whereas these are non-blocking statements. Now if you go for blocking statements, what happens means the a and b evaluation is done, and then after evaluating, the value is assigned to x. Okay, after the evaluation is assigned to x, then the next statement starts up. Okay, now the evaluation, that means here if you see this, this is LHS and this is RHS. Okay, so the after RHS evaluation is done, it is assigned to LHS and then goes to next statement. Here, if there are some more statements also after the execution of this particular RHS statement, then the assignment is done to LHS and then it goes on to next statement. So in this way, the execution is done in case of blocking statements. So why is it called blocking? Because it is blocking the other statements from execution until this statement is being executed completely. So that is why we call this as a blocking statement. When it comes to the non-blocking statements, just now we have read that evaluation of all after completion of all RHS evaluation only, then at the end step, at the time step, at the last time step, then the assignment takes place. This means here the a and b evaluation is done, okay, but assignment is not done. Okay, a next it will go to ax or bx or c. Evaluation is done, assignment is not done. B and negation of c, evaluation is done, assignment is not done. So after evaluation of b and negation of c, then the assignment for this particular statements x, y and z takes place. Okay, so now if you see the assignment, it will be done in x, y or z with their new values, right? So this is how the execution is done. While I am explaining this in this way, many of the students are having doubt that how they could differentiate between the blocking and non-blocking execution on the coding, like on the EDA playground or any other simulator also, how they could find this differentiation, like because they can't see much difference when they are using the same code with this as well as non-blocking as well as blocking. Yes, that is true. Why? Because for the basic course you can't see much difference, but when you are using the code in the test bench, and in test bench basically Verilog consists of four regions. Okay, active, inactive, NBA, which is non-blocking, as well as postponed. So when you are executing all the statements, okay, all these statements within your Verilog code will be executed within these four regions itself. So while you are executing a bigger code by using all the statements that executed in these four regions, then you can differentiate it. Okay, basically when you write a code which will execute in basically when you use any race blocking, you will be having race around condition. Okay, so in order to avoid that, you will be using non-blocking statements. When there is a case where race around condition occurs, in such cases you will be using this non-blocking assignment, and at that point of time you could see the difference between blocking and non-blocking execution. Don't worry about that, because in this video itself we will be discussing that also, right? So this is the difference between blocking and non-blocking statement. Hope you got an idea on how to differentiate between blocking and non-blocking assignment, and what is the actual difference between blocking and non-blocking statements. So when you are asked in the interview, you have to explain it in this way, like in non-blocking statement, evaluation of right hand side of the current time unit, like until in the current time unit all the right hand sides will be evaluated, and in the left side at the end of time unit they will be assigned to the left hand side. Okay, so that is the main difference between blocking and non-blocking statement. Now the next question is, what is the sensitivity list? Okay, have you heard this thing like sensitivity list? You'll mostly observe this in the always block. Okay, if you see here, in basically you are having like for three kinds of modeling techniques, which are data flow modeling, behavioral level modeling, and structural level modeling. In behavioral modeling you will be having two blocks, like initial block and always block. Okay, so within this always block you will be having this sensitivity list, which is mentioned with at the rate symbol before. Okay, at the rate sensitivity list. Like what is this sensitivity list basically? So basically the thing here is, initial, when it comes to when you go a little bit backward, like when you go for what is initial and always block, initial block means it will be executed only once, whereas always block means it will be executed multiple number of times. So how it will be executed multiple number of times? And also since it is executed multiple number of times, so always, if you don't put limitation to this always block, then this always block will be executed multiple number of times, and then it will enter into zero delay infinite loop. Zero delay infinite loop means since you didn't put any restriction on it, it will be executed continuously until the end of the simulation. Not only until the, as I told you, it will go to the zero delay infinite loop. Okay, I have clearly shown like how it will enter into zero delay infinite loop in one of my video. Okay, you can go there and check it out. And then, so in order to put limitation to this always block, we are using this sensitivity list. So sensitivity list is nothing but it consists of list of signals which want, which by using which these signals you can put the limitation on this always block. That means whatever signals that you are mentioning within this sensitivity list, only when there is a change in these signals only the always block will be executed. If there is no change in the signals, then always block will not be touched. Okay, so in order to make the always block to execute for limited number of times, you will be using this sensitivity list. And if there is no sensitivity list, then the simulation will be entering into, as I told you, zero delay infinite loop. So this is the always block. Okay, let me explain with a small example for you so that you will be easily understood. So if you see here in my program, I am using always block. So here I1, I2, I3 are my inputs. So for example, since there are only three inputs, I am using all the three inputs. For example, if I1, I2, I3 are my three inputs, but I want to change my always block only when there is change in I1 or I2. Then what happens? Always at the rate I1 or I2, you will be beginning your always block and you will be writing your logic everything. Okay, now what happens? That means when there is change in I1, this always block will be executed. When there is change in I2, this always block will be executed. But when there is change in I3, this always block will not be responding, because in sensitivity list you have mentioned that if there is only change in I1 and I2 only, this always block should be responding. So that is why if there is any change in I3, this always block will not be responding. Okay, this is how you will be using your sensitivity list. For example, if there are many number of signals and you want to include every signal that you have used in your code, then instead of writing all the signals, like instead of mentioning all the signals in a long line like I1, I2, I3, I4, I5, instead of mentioning all the input signals, you can just keep a star. Okay, star refers that for any change in the input signals that you have mentioned in your code, the always block will be responding. Okay, so this is how you will be using the sensitivity list. Now coming to the next question, which is dollar monitor, dollar display and dollar strobe. So explain about these three things. And also many of you have asked me like what is, and sometimes they will be asking interview questions like what is the difference between these three also. Basically it's either a difference or it is either explanation. So these are the commands, these are called as system tasks. Okay, so system tasks are nothing but these are the commands which are used in order to display something in your screen. Like for example, you are executing the code, and if you want to after executing the code, if you want something to be displayed on your output screen, then you have to use these commands. Okay, just like printf. Okay, in your C language, if you are familiar with C language, you will be having printf. Why do you use printf? In order to display something on the output screen. Similarly, in order to display something on the screen, you will use these three things. You will also use dollar $, there is also one more thing which is dollar $. So these are the four things which are used to display something on the output screen. Okay, just like printf. In C you are having only printf, but here you are having dollar monitor, dollar display, dollar strobe and dollar $. These four are called system tasks. Okay, so now why do we use these many things? Because we are designing the complex circuits, and also as I told you, in Verilog four regions will be present. So depending, in order to avoid any race around conditions, or in order to avoid any mismatches between the executions, depending upon the code, or by writing the code, you are having different codes will be executed in different part of code will be executed in different regions. Similarly, when you are displaying things also, these will be executed in different region. Like for example, in Verilog you are having four regions like active, inactive, okay, NBA, which is non-blocking assignment, and postpone. Basically these four. Okay, so in active, dollar display and dollar write will be activated. Okay, that means whatever that you are writing within dollar display and dollar write, they will be executed in active region. Okay, and similarly dollar monitor and dollar strobe will be executed in postponed region. That means after active, inactive, all the inactive statements will be executed, and all the non-blocking assignments will be executed. And then after completion of all this, then dollar strobe and dollar monitor will be executed. Okay, that means there will be no mismatch. For example, there may be some statements which will be which should be executed immediately, and there may be some statements which needs time to be executed, like because they need to gather all the information before being executed. So that is why you use such statements in this dollar monitor on dollar strobe. And whenever there are statements which needs to be executed immediately, you will go for active region. Okay, so dollar display and dollar strobe. And also when it comes to the difference between these four, dollar display and dollar write are almost same. I have already explained the differences clearly in one of my video. I'll link that in the description box. You can go there and check it out. But here dollar display and dollar write are almost same. And also dollar display and dollar strobe are also almost same. Okay, but the difference is that when it comes to different, dollar display is executed in active region and dollar strobe is executed in postponed region. And when it comes to similarities between dollar display and dollar strobe, here both will be executed only once. That means when you are displaying the inputs which should be executed only once, that means you want to display them only once, then you should put them in either dollar strobe or dollar monitor, sorry, dollar strobe or dollar display. But when you want to make that input or make that parameter to be executed multiple number of times, for example, if you are taking input A and input B, and if you want to monitor every change in this input A, but you want to display whatever that is there in B, okay, you don't want to monitor this B, then since you don't want to monitor it, you can just display it one time by using either dollar strobe or dollar display. But you want to monitor A, that means you want to see every change in this particular variable A. So whenever there is any change, if you want to monitor it, then you should use dollar monitor. Okay, dollar monitor system task is, so whenever there is any change in parameter, it will be displayed on that particular output screen by using dollar monitor. But dollar display and dollar strobe is not like that, they will be executed only once. So that is the difference. Hope you got the difference between all these four system tasks. Okay, now coming to, what does time scale 1 nanosecond by 1 picosecond mean? Okay, basically when you are executing in any of the platforms also, like for example EDA playground, if you see on the right side of your window, you will be seeing the time scale thing. Mostly when you see the time scale, it will be in 1 nanosecond by 1 nanosecond. Okay, this is the default time. Okay, timescale is nothing but when you are executing the particular your code, and when you are giving delays to that particular code, based on the timescale that you are mentioning, it will be considering the delays. Okay, I'll explain it clearly, don't worry about that. But the default timescale is 1 nanosecond by 1 nanosecond. Now what does 1 nanosecond by 1 picosecond mean? Okay, so it means, as I told you, all delays are interpreted in nanoseconds. Okay, so basically every delay will be interpreted in nanoseconds and picoseconds, and the fractions are rounded off to near picoseconds. Since it is 1 nanosecond by 1 picosecond, based on the delay that you are given, they are being rounded off to the picosecond level. But here, since it is 1 nanosecond by 1 nanosecond, the there won't be much differentiation, that the rounded off depending upon the nanosecond thing. Okay, I'll explain this with the example so that it will be clear for you. Okay, so this way, this tick time scale is nothing but this is the compiler directive. Okay, and basically, as I told you, the default time is 1 nanosecond by 1 nanosecond. But when you want to change that to like either 1 nanosecond by 1 picosecond, like that, what you will do is you have to use this compiler directive to time scale 1 nanosecond by 1 nanosecond. 1 nanosecond by 1 nanosecond, you need not give it. But if it is 1 nanosecond by 1 picosecond, you should give it by using tick time scale 1 nanosecond by 1 picosecond. Now if you see the code here, okay, I have used dollar display itself for everything. Now I am taking the delay, like if here, if you see, this is of 0 time unit, but here this is 0.45 and 0.50, 0.55. So these are the time units. Now if you are mentioning only 1 nanosecond by 1 nanosecond, then what happens, the if you see here, the precision time is 1 nanosecond only. Okay, this is called as precision time. Okay, if this precision time is only 1 nanosecond, so the delay will be happening only if it is zero point 0.5 greater than, like if you see here, only the delay value is greater than 0.5 nanoseconds only, then only the delay will be giving the rounded off value. If you see here, this is 0.45. Since it is 0.45, it is rounded off to 0 itself. And since it is 0.50, either it is 0.50 or greater than 0.50, then it will be considered as rounded off to 1. So here it is at time 1. Why? Because here this is 0, this is 0.45, which is not, which is rounded off to 0 because it is less than 0.5, and it is 0.5, so it is rounded off to 1. And here this is 0.55, so it is also rounded off 1, so 1 plus 1, which is 2. Okay, so this will be executed at two times cycles. This will be executed at one time unit, and these two are executed at 0 time units. Okay, so this is how the precision takes place depending upon the time scale you choose. Now if you do the same thing for 1 nanosecond, for 1 picosecond, as I told you, the precision will be 1 picosecond. Okay, so it will be rounded off based on picoseconds. So what happens here? If you see, this is 0, this is 0.45, this is 0.50, this is 0.55. Okay, so since this is picosecond, it is rounded off to picosecond value. So what happens? 0.544, this is 0, and 0.45 is, since it is picosecond, so it is 450. Why is it? Because it is 1 by 100. Okay, so it is sorry, 1 by 1000, so it is 0.45. That means 450. It is 500, which is 450 plus 500, which is 950. Okay, again 950 plus 550, which is 1500. Okay, so this is how you will be calculating the time scale by using 1 nanosecond by 1 picosecond. Okay, so basically when you are asked, you can just say it like every thing will be rounded off with nearest picosecond value. Okay, when it is nanosecond, it will, the precision time will be rounded off depending upon whether the delay is less than 0.45 or greater than 0.5 or greater than 0.5. But when you are taking the picoseconds, that means you are more accurate, you want to be more accurate to the time, so it is rounded off with the picoseconds thing, right? And then the next thing is, what are the primary differences between Verilog tasks and functions? So this you already know, like tasks and functions. When it comes to tasks and functions, now depending upon the usage of the particular code, like either you can use either task or function, both are the subroutines. It's nothing but a piece of code. When you want to execute it multiple number of times, you will be writing that code in either function or task. But in that piece of code only, if you want to use delays, or if you want to use non-blocking assignments, or if you don't have any return value, or if you don't have if you have more than one return value, so for all these things that I have mentioned now, functions are not useful. Because when you are writing a function, you should have at least one argument, and you should have at least one return type, and then you can't use any delays, or you can't use any non-blocking assignments, and also any time consuming thing that you can't use in functions. So if you are writing a piece of code which should be executed which doesn't contain any of the things that I have mentioned, then you can go for function. But when you want to use all these things, you will be using tasks. Mostly 60 to 70% time you will be using tasks instead of functions. Why is it? Because when you are designing the complex circuits, there will be non-blocking assignments, there will be delays, okay, there will be more than one output values, or more than one return type. So for all these things, since task is more useful, that is why you will be using 60 to 70% tasks. But if you don't use any of these things, you can go for functions. That is the only difference. Okay, so you can just tell it like that. If you want to use any of these things, you should go for tasks. If you don't want to use any of these things, like if you don't have any delays, if you don't have any non-blocking assignments, if you have at least one argument and you have at least one return type, then you go for function. Clear? So that is the difference between tasks and functions, right? So these are some of the interview questions. We'll be discussing some more interview questions in the next video. Okay, if you like this video, please share this to all your all those VLSA aspirants who are also preparing for interviews in Verilog. Also, if you have any doubts, please do kindly ask me in your in the comment box, and also do answer all the questions that I have mentioned in the starting of my video. That is all for today. Thank you all.